In this module, we're going to talk about the fundamentals of chemical equations, which are just like anybody else, searching for meaning and balance. So, what a chemical equation does is it describes a chemical change or a chemical reaction. For example, this right here. This is a chemical equation on top here, and it describes the reaction between this molecule, it's called methane, and this molecule, oxygen, to produce carbon dioxide and water. Now, in this chemical equation, there's some basics that we should know. One is the notation in parentheses after each of these compounds denotes what state it's in. G stands for gas, L stands for liquid, S for solid, and AQ, that's a Q, stands for aqueous. Aqueous means it's dissolved in water. It ends up in this reaction, everything's a gas, but not always. Something else about this chemical equation is we have these numbers in front of the formulas. These are called the coefficients, and they apply to just what comes after them immediately. For example, this 2 means there are 2 molecules of oxygen, O2. This 2 means there's 2 molecules of water, H2O. If there is no coefficient, that's an implied 1. There's a 1 there. Just don't write it. Now, when we look at, this is called a balanced chemical equation, by the way. That's the next thing. In a balanced chemical equation, we have the same number of atoms of each element on both sides of this arrow. The arrow tells you what's happening. What's to the left of the arrow, it's what's there before the reaction occurs. What's to the right of the arrow, oh, that's what's after the reaction occurs. The left-hand side are called reactants, and everything on the right-hand side are called products. The law of conservation of mass is that mass can be neither created nor destroyed. The way we apply that most commonly in this level of chemistry is what this says right here, a balanced chemical equation. So if we look at this and we count up how many of each atom there is on each side, we have the same number. For example, on the left-hand side of the arrow, there are 1, 2 carbons. On the right-hand side, there are 2 carbons. Now, here, the way to think about this is this 2 here times, there's a subscript 1 implied here. There's 2 carbons over here. Over here, there's a 1 in front that's implied, and there are 2 carbons within the formula. Just like that. If we do the same thing with hydrogens, how many hydrogens are on the left? 6, right? And on the right, we have 3 times 2 is 6. So hydrogens balance also. Oxygen on the left, how many oxygens do you count over here? Right. 1 times 1 is 1, plus 3 times 2 is 6. 1 plus 6 is 7 oxygens on the left, the reactant side. On the right-hand side, 2 times 2 is 4. 3 times 1 is 3. 4 plus 3 is 7. We have 7 oxygens. The law of conservation of mass is satisfied, and this is a balanced chemical equation. So, many times you will not have a balanced chemical equation, but rather you will have to balance it yourself. So here's how you do it. All you do is you adjust the coefficients, that is the numbers in front of the formulas, so that we have the same number of each element on both sides. Same number of atoms of each element. So this equation right here, butane, C4H10 plus oxygen. First of all, this is not a balanced equation as written because there are 1 times 4 is 4 carbons here. There's 1 times 1 is 1 carbon over here. There are 10 hydrogens over here, 1 times 10. On the right, there are 1 times 2, or 2 hydrogens. And oxygens, there's 1 times 2 is 2. And over here, there are 1 times 2 here, plus 1 times 1 is 3. So we have to get these numbers to line up. And the only tool we have to do that are the coefficients. So what number can we put in front of here? So we have 4 over here, carbons that is. We need 4 over here, so we just put a 4 in front, okay? Now we have 4 times 1 is 4. And we have the same number of carbons. Now let's go to the hydrogens. 1 times 10 is 10. 1 times 2 is 2. We have fewer over here, so we're going to multiply this coefficient by something to get it to be 10. Well, 2 times 5 is 10, right? So 2 times what is equal to 10? 5. Easy, right? So we put a 5 here. And now we have 5 times 2 is 10 hydrogens. Carbons are good, hydrogens are good. Now let's look at the oxygens. And by the way, there's a reason I left oxygens for last. And this is a little trick that'll help you out. If you see any element on either side of the arrow that's just by itself, like this oxygen right here, there's no other element combined with it. If you have something like that, then leave it for last, because whatever number you put in front of this will not affect any of the other elements or formulas in the equation. And if it did, if you left, say, this for last and then you put a number in front of here, it's going to change the carbons and the hydrogens, and you can get stuck in a vicious loop sometimes that way. So I left it for last, but let's look at it. How many do you see on the left? 1 times 2 is 2. On the right, we have, this isn't right anymore. Now we have 4 times 2 is 8. Plus 5 times 1 is 5. And that adds up to 13, right? We have 13 oxygens on the right. We need 13 on the left. Well, all you have to do to ask yourself, okay, oxygen is just right here. We need some number in here so that when we multiply it by 2, it's equal to 13. So, in other words, 13 times what? 13x is equal to 2. Do you see? That's the question. We need, excuse me, let me back it up. Let's not state it that way. Let's do it this way. 2 times what is equal to 13? Because 13 is what we need right here. We need a 13. So if we solve this, x is equal to 13 halves, right? So we can put a 13 halves here, no problem. Except, okay, so now that is a balanced equation, all right? We have the same number of each element on both sides. Check it. We have 4 carbons, 10 hydrogens, 5 times 2 is 10 hydrogens there. We have 13 halves times 2 is 13 oxygens here. 4 times 2 is 8, plus 5 times 1 is 5 is 13 over here. Everything's balanced. But here's the deal. When we say balanced chemical equation, what we mean are whole number coefficients, and not only just whole numbers, but the smallest whole number coefficients that will balance the equation. But that's easy. Once you get it balanced this way, whatever's in the denominator here, mostly it's 2. You just have to multiply everything through by that, and that will be your smallest set of whole numbers. So 13 halves times 2 is 13. 2 times 1 is 2. 2 times 4 is 8. And 2 times 5 is 10. Now that is our balanced equation. Let's make this a little prettier. Yeah, not much. That's the smallest set of whole numbers as coefficients that will balance this equation. That's our answer. Now, one last thing. On multiple choice tests, sometimes I ask them this way, questions about balancing. I say, when this equation is balanced, what is the sum of the coefficients in the balanced equation? So here's our balanced equation that we just figured out. And the answer to this question on a multiple choice test would be 2 plus 13 plus 8 plus 10 is 33. Watch out. One thing that people sometimes do is if there's a 1, we don't write it, but they forget to add that 1 in. Watch out for the 1s.